talk about trigonometry. There are 6 trigonometry functions, namely sine, cosine, tangent, and its inverse, secant, cosecant, cotangent. The relationship between sine is equivalent to 1 over cosecant, or you can also write cosecant equals to 1 over sine. Likewise, you can write secant as 1 over cosine, or you can write cotangent equals to 1 over tangent. An additional trigonometry identity you have to understand is tangent is equivalent to sine divided by cosine. So cotangent, on the other hand, is going to be cosine divided by sine. For every type of trigonometry functions, some of them could have varied amplitude and period, especially when it is sine and cosine related. For example, for sine and cosine functions, amplitude and period can be categorized as one group. On the other hand, for tangent, it can be categorized as another group. So when it comes to sine and cosine, you need to understand that y equals to a sine bx, amplitude is basically the coefficient of that sine and cosine functions. It's also telling you how much of a fluctuation, how big is the magnitude of the fluctuation this sine and cosine curve may grow up to from the starting line, the mean line. If this value is 2, this value is negative 2, it will mean that it has a magnitude or amplitude of 2. In sine and cosine, the relationship between period and this value b is related as period is equivalent to 2 pi over b. When you have an equation that looks like this, y equals to 3 sine 2x, it simply means that its amplitude is 3 and its period is 2 pi over b, whereas you can identify the values of b, so you understand that its period is pi, and it will mean that it takes pi amount of time to finish one cycle. So this is the representation of amplitude. On the other hand, that is a representation of period. We should understand some of the basic equation of trigonometry functions such as sine, cosine, and tangent. We already have shared with you A is related to amplitude, B is related to period, and the values of C is actually related to the horizontal shift. The horizontal shift. If there is an additional value at the end of it, we call that a vertical shift. And so in this particular case, y equals to 2 sine x plus 1, we can identify it. A equals to 2, B equals to 1, and there is a vertical shift, usually represented by the alphabet K to be 1. So that's why we say amplitude is 2, period is 2 pi. Why is period 2 pi? Because of the formula, 2 pi over b. So b is 1, 2 pi divided by 1 is 2 pi. And the graph is shifted by a unit of 1 in the positive y directions or upwards. Here are some of the trigonometric identities. Literally everything is derived from sine square plus cosine square equals to 1. So in these questions, we are going to share with you how solving trigonometric equations can be done. If you were asked to figure out what is 4 cotangent equals to tangent, what you need to do is you need to convert cotangent in terms of tangent so that you have the same trigonometric functions in a single equation. 4 equals to tangent square theta. So tangent square theta minus 4 equals to 0. And this can be factorized. You understand that a square minus b square equals to a plus b, a minus b. So we are utilizing this factorization, and so we can rewrite this as tangent plus square root of 4, which is 2, tangent minus 2 equals to 0. And so you will be getting tangent equals to negative 2 as well as tangent equals to positive 2. Realize the answers to be in inverse 2, theta equals to 63.4 degrees. According to the STC diagram, tangent equals to negative 2 during the second quadrant. So it's going to be theta, pi minus theta, pi plus theta, and negative theta. So pi minus 63.4 degrees, theta equals to 180 minus that, the answer is 116.6 degrees. So these are the two answers for the first questions. Now, to have a better understanding the general way to solve any of these trigonometric equations, you will go according to the following steps. Step number 1. Rearrange so that you will be able to solve or rewrite data in terms of inverse of a trigonometric equation. It can be inverse sine, inverse cosine, or inverse tangent. Number 2, we're going to find the principal angle. The principal angle is simply the answers that is in the first quadrant. In another word, it is going to be the acute angle. Number 3, we are going to apply the STC diagram. And the STC diagram follows the following order, or the following pattern. Is always like that, pi plus theta as well as negative theta, or 2 pi minus theta. So everything in the first quadrant is positive. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant, as well as only cosine is positive in the fourth quadrant. Depending on the type of expressions that you are encountering, you will then present your answers in the specific quadrant. Last but not least, sometimes you have to do the necessary rotation depending on the domain provided. In the second questions that we have over here, we can again practice this particular idea. So 2 sine theta over 2 minus 3 equals to 0. Sine theta over 2 equals to 3 over 2. This is an example that there's no solutions. Now, how do you know there's no solutions? 3 divided by 2 is 1.5. On the left hand side, you are having a sine equals to 1.5. Now, from the previous slide, you learned that in this particular case, the values of a is 1. In another word, no matter how this graph looks like, the maximum value that it can get to is positive 1. But you're trying to find the point of intersection between 1.5 and 1. Obviously, there's no such a thing. So this is the case where there is no solutions. It can also be verified if you try to apply the values of inverse 1.5. Inverse 1.5, you're getting a math error. So that's the reason why you are not going to get an answer for these questions. Sometimes you also will be asked to use identity to resolve certain questions, and we will see more practices in the upcoming examples. But the two identities you must remember is sine square x plus cosine square x equals to 1, as well as tangent equals to sine over cosine. In this particular page, you can see how we may use the trigonometry identity we introduced earlier to prove the left hand side equals to the right hand side. So we would like to figure out sine x tangent x plus cosine x should be equivalent to secant x. Now the way to do it is by converting every single terms into sine, cosine or tangent. Well, to be honest, even simpler, just make it into sine and cosine, because tangent can also be expressed as sine and cosine. So you will realize sine multiplied sine over cosine plus cosine is what we are having from the left hand side. And from this step onward, you can do the necessary multiplications. You can also do the necessary combining the fractions, so cosine, and you will then get sine square plus cosine square. You learned from the previous slides that there's an identity of sine square s plus cosine square s equals to 1. So 1 over cosine square. Cosine x is the final remaining product, and that is also equivalent to secant x. So that is how this may be proven. Here are some key summaries. You need to understand what is amplitude, period, know some of the basic graph of sine, cosine and tangent, trigonometric identities, and then you need to know how to solve the questions. The basic graph of sine, cosine and tangent: sine looks like this, cosine looks like that, and tangent looks like that. This is tangent, this is cosine, and that is sine.